Hello YouTube, my name is Fag. Welcome to my channel. Hope you enjoyed this video. Make sure to like, comment, and subscribe. And here we go. It is called 2005 World's Strongest Handheld Laser. And this came as a suggestion from either, was you Aloha or was it Venom? Let me check real quick. I'll make sure I get this right. Haven't said it was packed for the next 6 months. I just want to get this right real quick. Give me 1 second. I got a lot of user suggested videos today, so yes, aloha. This is suggested by you. I was right. Aha. Now let's check out this world's strongest laser. This by styropyro. Interesting name. Interesting name.
This video is sponsored by Opera.
The legal power limit for a laser pointer is 5 milliwatts. Well, I think it would be funny to build one that's 50,000 times stronger than that.
Now, I've showcased a lot of ridiculous portable lasers on this channel.
That looked almost like a lightsaber blade, didn't it? We were shined up like that. This guy's room is saving the good way. I think so, pal. He does have to play with lasers, apparently.
But so far, none of them come close to that kind of power.
Even my strongest laser, which was world record breaking when I built it, isn't even half of this level. Now, considering the advances in laser tech since I made this thing, I think it's time to build a laser pointer that just completely blows it out of the water.
You
Now, I'll
chipmunk
admit that
voice.
more power isn't my only motivation here. This laser is horribly designed, and it is just plagued with issues. Not only do I want the next one to be stronger, but I want it to be good and packed with cool features.
Like the last one, the heart of the new laser is going to be the best diode array that the Chinese black market has to offer. The kicker is that there have been 5 years of improvements on these things. The new arrays are stronger, brighter, and more efficient.
They still carry the same dubiously legal...
You know how that serial number was scratched off so you couldn't buy the exact same thing? I guess that's his way of saying don't try this at home. I think this guy is trying to actually make a Star Wars blaster. I think that's his ultimate goal from what I've seen so far.
charm as the last ones, though, as they still ship with scratched out part numbers, and the manufacturer still denies that they even exist. Now, as long as I can input money into eBay to acquire these, then I'm not going to complain. I mean, honestly, the feeling that I'm not supposed to own these really adds to the appeal.
I've hooked a new array up to a lab power supply as a test, and although I can't push it to full power on this thing, it gives an idea of the insanity that I'll be working with here. The
Flashbang! Oh, that's bright.
array is the same physical size as my first one, but with more emitters packed in the same area, and according to the sketchy datasheet, it's rated for 161 watts of output power. I'm actually going to attempt to push it far beyond that
Chinese
using
is
some
a great
overclocking
fun
techniques.
for the whole family of
But that's
science
going to take
nerds
more
or
careful
needs.
design than this piece of trash I
I thought you
built
said
5 years
nerds
ago.
far off.
Now, if you think I'm exaggerating when I say this thing is poorly designed, well, it randomly quit working a few months ago, and I don't even know.
Really? So they scratch it off because it's illegal to sell in a lot of places. Because it's so strong. Okay, that makes sense. You don't want the wrong people getting that and hurting other people. I see how that makes sense. But to be able to get something like that on eBay, though, if it's that illegal, surely it's not that illegal. But what do I know? I don't go on eBay much.
Why. So let's open it up and see what's going on. Now, it definitely smells crispy under here, but I don't actually see anything that's like burnt up. Well, it looks like it's the batteries. They are completely fried. I wonder if the dead batteries has anything to do with how you have to like smash these batteries into the laser. Like seriously, they don't really fit in here. You have to like crush the batteries. And like, yeah, if there's one thing that lithium batteries love, it's to get crushed like this. And the worst part is that because I didn't build a charger inside of this thing, you have to, take it apart every time and then crush the batteries again in like a slightly different configuration. Oh man, I'm very happy that this thing never operated in pipe bomb mode. The cooling in this thing sucks too because it's just
Oh, that was dubious, wasn't it? Hope it's not foreshadowing. You're not supposed to lithium batteries. Then we'll go do the kaboot. Yeah. Lithium batteries are known to do that. I've seen instances where somebody working on their house, right, and have their phone sitting there. They'll drop a hammer on it and it'll start smoking and burning. So yeah, be careful with your lithium batteries, people.
this giant chunk of aluminum that doesn't have any real connection to the case there, so heat just builds up without anywhere to go. And then these laser drivers kind of suck too. I mean, if I would have used chips from the Century, they would be a lot more efficient than they are here. But you know what really cursed this project from the beginning? The very first sentence of the video.
Hey everybody, it's the year 2020 and I want to celebrate. Now typically on this channel, I like building crazy contraptions.
Yeah, that didn't age so well, did it?
You didn't eat that very far. You should have threw it like a frisbee.
So this time, I'm not going to celebrate that it's 2025, but instead I'm going to celebrate the fact that my channel has now made it 18 years on this platform without getting banned. And yeah, it's not like I needed a reason to build a big
18 years he's been doing this. Wow, he's a veteran of the streaming game. Kudos to him. I'm impressed.
bigger laser. But if I'm going to correct the issues from the first video, I might as well be comprehensive.
He
The
got that
one
right,
thing I
Aloha.
did like about the first laser was the radar gun housing, so I bought another broken one on eBay. I took it apart and pulled out the cool old microwave circuitry, and then added my own control circuits, a charging port, and a bunch of switches. Next, I picked up some batteries, and assembled a pack using a battery management board. This should hopefully reduce the risk of catastrophic failure, or even a boring failure like over-discharge. I needed a circuit to carefully drive the ever-living daylights out of the array. Usually I use an IC from the 70s for this, but in the interest of efficiency and size, I dead-bugged some modern purpose-built ICs for this task. Now I took a risk here, since I built these to far exceed the array's ratings.
This array is rated for 3.5 amps of drive power, so I decided that 4.7 would be a better number. Now yes, this carries the risk of destroying it early. However, with proper cooling, I think it should hold up. This will give up to 255 watts of output
He's definitely
power,
pushing that
which
to the max, ain't
obliterates
he?
the last one at 100.
I also added a PWM feature to the driver for audio-visual effects. I first tested this feature on a week
He better hop on his silly. You see that? Playing around the laser adventures. Oh my god. This guy needs to be more careful.
array, and it worked better than I expected. That sound you hear is actually coming from the laser hitting the wood. Now this is where things got difficult. I still had cooling to deal with, and since I didn't want to machine an elaborate heatsink, I figured water cooling would be the better option. I picked up a water block designed for CPUs, along with a pump and radiator, and assembled a cooling loop. However,
Now, I didn't see him apply thermal paste to that, so that might be the issue if he's trying to cool. Yeah, there you go.
jamming all the plumbing into the case along with the electronics and batteries turned out to be very difficult. In fact, not long after finishing the laser, the control electronics burnt up randomly, and then when I rebuilt them, they all burnt up again. The circuitry isn't even complicated, but because it was all free-wired, it was incredibly time-consuming to redo.
I think this guy is pushing his power too hard. You already said he's overpowering it. Supposed to use a circuitry that can't handle that much power to begin with. So I think that's his problem, really, just overpower. Not only did he burn a hole in the ceiling, he blew a hole in the white spray foam ceiling. That shit is almost impossible to light on fire with a laser. Is it really, Aloha? I was not aware of that. Of course, I don't play around with lasers, so. Although, have you guys ever seen the Gauss rifle? I wouldn't mind having one of those to play around with.
I never actually identified that problem, so when I finally decided to try building it once again, I added all sorts of fail-safes against shorts and voodoo voltage spikes. The third time was the charm, though, it seems, as this version survived past initial testing.
I actually want to apologize to all my channel members and Patreon supporters that followed this project, because it took so much longer than I expected. However, as you're about to see, this is the craziest handheld laser on the planet, so I really hope it was worth the wait.
With an output of 250 watts, this laser eclipses the
So you work with lasers that are 10 times stronger than this little? Oh, that's neat. What do you use those for? Like precision cutting or engraving or? I just curious. You don't have to answer if you don't want to. Just curiosity.
threshold for the highest laser danger rating by a factor of 500. That means that just 0.2% of the laser's power is already considered an instant blindness hazard, as well as a fire hazard. The luminosity of this laser is especially impressive as well, having more than quadruple the brightness of my 100-watt laser, as this one is a brighter sky blue color. It's funny because, even though I built this thing, part of me still finds it hard to believe that a device like this is
Man, they got a filter over that camera, and that thing is still bright as hell. Oh, so you use it for cutting SLS printed metal. Neat. Well, that's interesting to know. Thank you. Look how bright that is. He's got a filter over that, and that's still bright.
even possible.
Let me give you a quick rundown of the features of this laser. So this switch right here turns the whole thing on. Then you can see the readouts there for the battery voltage and temperature. Then these switches right here are what turn on the water pump and the cooling fans, which are impressively quiet, I have to say. Then the safety switch is right here, which of course arms the laser. Then these knobs right here control the PWM frequency and duty cycle. But for the time being, I'm just going to leave these maxed out. And then the trigger right here is what finally fires the laser. Pretty cool, right?
He dropped the concrete on fire.
I'm sure you're wondering,
I don't know if I kept the concrete on fire, but I'm pretty sure he had something on that to do that. That quickly, at least. You usually want to pilot at several thousand feet with that laser. You can do that with just little pin lasers you get at any gas station. That's why if you point at airplanes, you get in big trouble. Hi, Spike. How you doing? Nice to see you. You got the new emotes? I probably got them in today. But yeah, even those little pin lasers can blind somebody, even a pilot. That's why if you ever get caught doing that to a plane, they will fine you for that.
what can you burn with the world's strongest handheld laser? Well, a lot of things. Now, spoiler alert, the real crazy stuff happens when you stick a lens on front and focus the beam to a tiny point. But let me first show you what the unmodified beam is capable of.
Let's start with a block of wood. The beam ignites the wood basically instantly, and you can even hear a little explosion as the pyrolyzed vapors catch fire as well. The small portion of the light that reflects off of the wood is able to illuminate my entire shop. That's a lot of light. Cutting electrical tape is a classic demo for a strong handheld laser. But of course, this laser is well over 1,000 times more powerful than what's needed to accomplish this. The tape is sliced as fast as I can wave the beam across it. The same goes for
Like
any
butter.
sort of thin plastic I throw in front of it. A plastic cup is quite a bit thicker than the tape, but it does
Really? I don't know where the hell. What's a J-Dam? That, I'm assuming that's either some kind of military, police, or is that like a artillery of some kind?
doesn't seem to have much meaningful effect against the laser. The beam punches straight through it without issue.
While we're doing classic experiments, let's pop some balloons.
Ah,
That was pretty quick.
While we're doing overkill, matches are unsurprisingly no match for the laser. Slow-mo shows that they make it about 2/100ths of a second before catching on fire. Newspaper
Damn.
falls in the instant ignition category as well. Just barely clipping the beam is enough to light it on fire. Any paper product
I don't like how close he get his hands to that laser. If that laser's that strong, he needs to be a little more careful about that.
is this way really, but paper bags make an especially satisfying sound from the flash pyrolysis. You might think that solder would be a challenge considering how reflective it is, but nope, it melts nearly instantly. A CD was the first real challenge for the laser. Of
Yeah, I
course,
did.
it still
Had
caught
that
on
stuck
fire
to it.
instantly, but it took a while for the beam to punch all the way through. I think the sooty flame in front was attenuating the beam before it could hit the plastic. The end result was pretty neat though.
Now, those CDs have a very reflective, thick piece of metal in there. I'm glad that didn't reflect back on it partly, but that also might delay the laser from burning through it too. This guy actually messes with microwaves for fun. He knows what he's doing. Well, I should hope so. I mean, he's building lasers. He's been doing it for 18 years, so I'm definitely impressed by that. It's just for his demonstration purpose for the video. I kind of wish he'd be a little more careful. I don't want him to get hurt, you know?
I briefly talked about the PWM feature, and I want to show you what this does when it comes to burning. By switching the laser at audio frequencies, the target actually makes sound as it vibrates from thermal expansion and contraction. In fact, this effect went far beyond my expectations. Now I'm wondering about the possibility of building a musical laser. I'll have to save that for a different video though. Alright, now it's time to actually test this laser's true destructive power. I'm going to stick a big f-theta lens on front in order to concentrate the output to a point and maximize
I had a
power
big old
density.
lens.
Everything I've shown so far can be accomplished by weaker lasers, so this is the point where I enter uncharted territory for a handheld laser. Let's start by trying something that the last record breaker couldn't accomplish, melting a penny.
Alrighty, let's try melting through this penny. It's on fire! What? Oh, that's crazy. I wasn't expecting it to burn. It burned the zinc inside. That's nuts. Wow.
It's hard to see the actual flame when there's so much blue light from the laser, but I did manage to repeat the effect and get a flame to sustain for a bit after turning it off. And as a bonus, it left a bizarre frozen smoke remnant of zinc oxide. The fact that the
Oh, that is cool. I thought that was actual smoke coming off that. That's actually zinc oxide that was vaporized and cooled back down. Neat.
laser literally lit a penny on fire is an astonishing result to me. I've done all sorts of mad science experiments with pennies over the years. I've dissolved them in acid, treated them with cyanide, hit them with 1,000 amps, blasted them with other lasers, but none of those methods ever managed to light a penny on fire. Even torching a penny doesn't ignite it, it simply melts it. I think the reason the laser can ignite pennies is due to extreme local heating. The zinc that's being exposed to the laser is likely reaching its boiling point faster than it can transfer heat to the rest of the penny. Then the resultant jet of zinc vapor goes on to ignite on contact with air. At that point, the heat from combustion can sustain the flame for a bit even after the laser is removed. I think that explanation makes sense, at least. For the next experiment, let's see if the laser can make it all the way through an aluminum can.
I'm
pretty
sure
sure
it
this thing will
can.
burn through one side of the can, but to go all the way through, that's what I'm not quite so sure about. But let's give it a go. Oh, wow, it was just instantly. This thing keeps surprising me. That's insane.
The last record breaker couldn't defeat an aluminum can either.
You know, they joked in the 50s about making death rays and stuff. This guy has actually done it.
So the increase in power is pretty obvious here. Let's see if the laser can open up this glass soda bottle.
What could possibly go wrong?
Oh,
Oh my
I'm
gosh!
right. What happened? Yo, look at that. Look how it's reflecting back at him. See, that's what I'm concerned about, right? His experiments and stuff. I know it's spread out, but that was a tight beam coming back. Ooh. No, but what happened was the laser passed through the glass, and heated up that liquid to the side. I just went pop. Ouch, boom. New wallpaper. Yeah, new wallpaper indeed.
Oh my gosh! Oh, I'm so happy it exploded like that. Oh my gosh. It was like a glass balloon.
That was fun. Let's pop another one for good measure.
Oh. Did you hear that sound in slow-mo? That sounded wicked, didn't it? I know he has specialized eye protection on, but it still worries me. Yeah, I know he knows what he's doing, right? Otherwise, he wouldn't have been doing this for 18 years. I still worry. I care.
Well, it's not exactly an ideal bottle opener there, but that was pretty cool. Now my shop is gonna smell like beer, or I mean soda.
I wonder if the laser is strong enough to punch through drywall.
Okay, this material is supposed to be a fire retardant. That's why it's standard building material in homes in the US.
You're kidding me.
Oh, the bird through it.
Wow. It's white. You'd think that it would like reflect off all the light. That's bonkers. I would have never thought that that would be possible with a hand.
And that just proves that fire retardant doesn't mean fireproof. Look how small that hole is, too. Damn.
Handheld laser. That is ridiculous. In the early days of big pulse lasers, before there were precise methods of power measurement, lasers were measured in Gillettes. Now, this literally meant how many Gillette razor blades the laser could shoot through in one shot. Now, this kind of measurement doesn't translate to a laser that can operate continuously, but even so, I want to try shooting through some razor blades.
I even found some Gillette blades from the time period of early lasers to try this with.
All right, moment of truth. Is the laser at least one Gillette? Let's find out. Oh yeah, not even a challenge. That was instantly.
Hey, you're slowing down.
In fact, I want to see if I can actually cut this thing in half.
Ooh, like butter. Man, that is strong ass handheld laser.
Wow. Yep.
Now let's see how fast it can punch through 5 blades in a row.
All right, here we go. Jeez. That is so wild. Wow, that's terrifying, honestly.
The way to make the Gillette measurement make sense with my laser is to convert it into a rate, essentially going from units of energy to power. Since the laser burned through 5 blades in 0.9 seconds, I can say the laser has a strength of about 5.5 Gillettes per second. Let's try a utility blade that's more than 6 times thicker than the Gillette.
Ah.
No problem there.
Looks like he's slowly working his way up to, thickness of metal. Bring the high caliber steel to the bitch as well because it is so reflective. I can imagine so, right? Plus it's been hardened, right? And he went to the thicker blade with very little issue. It just took a little bit longer than the blades.
Considering how fast the laser can melt holes in these razor blades, now I'm going to try welding 2 of them together.
All right, time to test out if it can, if this thing can weld. I can see it glowing and sparking. That's gonna be a good sign. Well, I melted through. I don't know if I actually welded it, but let's take a look there. Yes, it did. It actually welded it. No way. And look at that. It actually welded that. Now, if anything, I should have moved faster just because where I held it too long, It burned all the way through. But it legitimately is holding
Cybertruck door. So how the arsenal was that was still being converted into plasma as it got there. Was it really? Well, that's neat. But what he did there was a form of fusion welding. That is, welding with just heat with no sticks or other thing to go with it, like say brazing using special rods, or wires or something like that. That is just straight up welding with the heat, which is neat to see.
that together.
Let's see if the laser can melt through copper wire.
All right, here we go. Oh, it's melting. I think it's gonna work. Yes!
Say, that doesn't surprise me, 'cause it already burns to a pity, and the pity has a copper coating on the outside of it. Granted, not that thick, but it's still copper.
Well, there it is. Wow. Well, this thing's really going toe-to-toe with a microwave. I would have never guessed that.
This seems like a stretch, but I'm going to try punching through this piece of titanium here.
Nah.
All right, let's see if this works.
How much missed that, Silver?
No way.
Oh, it got right through titanium.
What? It just
Damn.
shot through instantly. It shot a huge hole through it.
And you see it warp after you turn the laser off? That metal is still warping. It gets more than the same power, do you think? If he's converting it to a plasma that's still at that point between 5,000 to 6,000 degrees. Holy crap, that's hot.
Just instantly. That's insane. Now, titanium is not something that just melts easily. And as a demonstration, I have this torch here. So, I can hold this here all day. It's not gonna melt. This one's really surprising to me.
In my last video, I built a 20,000 watt microwave, and in one of the experiments I used it to make ruby. However, the setup was far from ideal. It was impossible to concentrate the energy, and my containers kept exploding. Thus, the rubies I did manage to make were pretty small. I'm going to see if the laser can do it better.
So he's trying to make actual rubies? Okay.
The starting mix is the same as last time. Alumina powder with a couple percent chromia added,
I
which
need
I
to fish
got
my
from
legs real quick.
Nighthawk and Light's
I'm
video
not
on
going anywhere
cooking
to
up
fish my
rubies
life,
in a home
guys.
microwave oven.
Yeah, don't ask me about the name on that one. All right, let's try cooking some ruby. Now it's sparking. I don't know if it's actually. Oh, it's so hot. It's just glowing so brightly through these goggles. Oh wow, that is so hot.
Looks like it's
Oh
on
my
fire.
I had no idea it was like just melting it so well. It's crazy. I think I just made a huge ruby too. No way. I can't believe it's gonna work this well. This laser just keeps surprising me. Oh, it melted like a big old glob. I think it like beat the daylights out of the microwave actually. I had no idea.
I didn't know there was such a thing, huh? I always thought rubies were just for, jewelry and stuff. Oh, that's interesting to know. I mean, I know they make dope diamonds or grow diamonds in labs, but I didn't know they could do the same thing with rubies.
That it was cooking that well. And look, it just made an enormous, huge ruby. What? That's crazy. It's huge.
Wow.
What? It just made this giant ruby. That is crazy. In fact, I'm going to go ahead and give this guy a pluck. My gosh, it's an enormous, enormous ruby there. I'll clean that off and make another one here quick.
This turned out to be a really reliable method to make big rubies, and it blows the performance of the microwave out of the water. Even freehanding the laser produced bigger rubies than I was able to get.
So, when they make industrial rubies, the cold step was to make it abrasive. That makes sense. But I didn't know this was how they were made. Not with this particular process, but you know what I meant. That is so cool. I guess rubies are the girl's best friend. Although they would match my hair and eyes, wouldn't they?
It via the microwave. I'm very impressed with the size of these. I've never offered merch before, but I don't think anything could beat laser-grown ruby as my first product, so I made a few extra to offer my viewers. Check the link if you're interested. I'm curious whether white sand is reflective enough to resist melting in the laser beam.
Oh yeah, just instantly melting.
Making
Oh my gosh,
glass.
it's so bright. Even through these goggles. Oh yeah. Wow, look at that stuff glow. But it's white too, like you'd expect it to just reflect it all away, but nope. It just melts straight through it. That's just bonkers, man.
Considering
I appreciate the offer, pal. Shepherds, thank you for the follow on kick. Thank you. It's much appreciated. I appreciate the offer, pal, but I don't want you getting hurt or doing anything illegal or something.
how well everything else has worked, I'm going to try zapping tungsten wire. Now, as a reminder, tungsten has the highest melting point of the metallic elements.
This is crazy that I'm even gonna try this one. Oh my gosh. Oh, it's so close. I don't know, man. I'm gonna have to get the focus better. Oh, it was close.
Tungsten withstood it. That's like what, the hardest metal there is?
Close, but I think it was slightly out of focus. So I'm gonna move this back just slightly and try it again. Alright, I think I have it lined up better this time. Oh. Yes! It worked!
I got to it.
Oh my gosh, I cannot believe that. That is insane. I would have never expected this laser to go like toe to toe with a
So tungsten melts at around 6,200 degrees Fahrenheit. Ooh, that's hot. That's hotter than steel.
microwave. My goodness. That's crazy.
Hi, bro. 0451, welcome. How you doing today? Yeah, apparently he made the world's strongest handheld laser. He's been cutting through all kinds of things going up in density, and he just cut through a tungsten wire. It's neat.
It's crazy.
The wire burned here instead of melted, but even so, that still takes some incredible temperatures. The only other extreme material I can think to test the laser
I hope
against
I
is
got your
diamond,
name right.
so I picked up some synthetic diamonds to laze. I honestly don't know what to expect from
Roll,
these.
rail.
So by some chance, can this thing burn through diamonds? Let's find out. Oh, they're burning. They are absolutely burning there. Oh, I think one.
He just made a diamond explode with a laser. He killed my best friend then. Yeah, I'm working on it around, I thought I'd have it, but there's a delay in my bank on getting it transferred over to where it needs to go. But I am working on getting it. I apologize for the delay. What's the point? It was a vapor point. So is the temp that still turns the gas. Oh, okay, I get it now. Thank you for clarification.
Just exploded. Wow. It actually lit a diamond on fire. Wow. That's amazing.
I guess it shouldn't be so surprising that diamonds burn, considering they're just carbon, but it still takes a very hot temperature to ignite them, and they reflect a large portion of the laser light anyway. In fact, the diamond reflections are particularly scary, since the crystals reflect intact portions of the beam and result in a terrifying disco ball of insta-blindness. My goggles protect my eyes just fine, but I'm glad none of the beamlets hit my cameras, as I'd hate to destroy all my cameras again.
Oh, that's interesting how it like changed allotropes there.
Yeah, I know,
Turned to,
right?
like,
I made a joke earlier about Desiree. He actually did lick one.
amorphous carbon there in the center, and you can still see some
Let's go, ball of doom.
unlaced diamonds there on the side. Oh, that's weird. That must have got really hot. I could see some of them burning too. I could see the sparks flying out. But yeah, it changed the allotrope.
Lithium coin cells aren't exactly as tough as diamonds, but they turned out to be a lot of fun to zap.
Now, definitely do not do that at home. Right? There's all kind of toxic gases released if you do something like that.
Their metallic lithium content makes them quite pyrotechnic when they fail.
Heck.
Interestingly, the effect depends on which side is hit by the laser. Blazing the positive side is what gives a rocket-like effect, with flames colored red from lithium's atomic emission spectrum. Hitting the negative side is what makes them pop more violently.
Heck.
Oh, there's lithium burning on there. Oh boy. One of the batteries even splattered some molten lithium on the laser lens. Oopsies.
So I have an old style ping pong ball here. Now these old style ones are flammable because they're made out of nitrous cellulose. But the problem is it's hard to find those locally, so I have to order them online. But because I've bought these online, now I get sent this physical spam in the mail from Paddle Palace.
Sorry.
It just sounds so bad. But I don't play ping pong ball. All I do is just blow these things up with lasers. So anyway, I'm going to shoot through one with this huge laser here.
And yeet.
Yeah, just instantly. Typically, when I make videos about my lasers, I show you all the cool stuff that they can do and leave out what they can't. But you know, some of the failures are even more interesting. So, what are some surprising things that this laser struggles with?
Burning a hole in a CD case is a classic demo for a powerful handheld laser. Going back to the archives, it shows that a 1-watt laser takes a few seconds to pull this off. So, does this laser do it 250 times faster? Nope, it's actually slower. What's going on? Sometimes there's a paradoxical effect with lasers, where increasing the power weakens its effects on materials. Flames, smoke, or even plasma from the laser hitting the target can absorb most of the laser light and protect the material beneath it. This effect is very prominent with pulsed lasers, and explains why this laser can pop craters into tungsten, even though it struggles to pop a balloon. The CD case immediately shot a jet of sooty fire when it was hit, and I think that played some protective effect. I've also noticed that some materials can become self-healing to an extent when more power is applied. For example, my laser welding system actually cuts steel faster with the power turned down. At full power, even when the beam does punch through, the hole tends to immediately close back up when the laser is turned off. The reasoning is that the higher power results in more molten material that can fill in gaps. I tried another CD case at roughly 10% power using the PWM feature. Sure enough, it burned through faster with less power.
That's interesting. It was actually more effective when you turn the power down.
Then tried it at full power, but slightly out of the focal point to lower the power density. Since it didn't catch on fire, the laser shot through almost immediately.
I always say that most problems in life can be solved with very powerful lasers. And although this may seem like an exception, the reality is that the problem will go away if you throw even more power at it. The issue is that more power isn't always possible, at least based on engineering constraints or even the current state of technology.
Mirrors also showed some self-healing effect. Ironically, it was the shiny part that burned, while the glass simply melted and prevented total burn-through.
Another surprisingly difficult task for the laser is igniting flammable liquids. For example, I've got this glass of butane here, and oh, look how angry that is. They're just like boiling away. Just the tiniest little spark is all it takes to turn this thing into a fireball. So, what happens if I shine the laser at it?
Good nights. On a mission to help kids stay
Alien.
dry through the night. Never stop dreaming.
Absolutely nothing. The thing about flammable liquids is that it's really their vapors that ignite. It's easy to imagine a laser as just a long-distance torch, but unlike a flame, the energy from a laser has to be converted to heat via absorption by a material. The problem with vapors is since they're transparent, they don't absorb light and thus they don't heat up. You can get around this with a laser many thousands of times more powerful, as at that point you can initiate a spark via the electric field. But for a laser like this, I have to cheat and add something else to burn that can then go on to ignite the liquid. I figured that the plastic case of a lighter would provide enough flame to ignite the vapors released when it pops, but even this turned out to be a challenge.
Are you
Hi.
serious?
I eventually
Well, what's happening there more than likely, right, is, if he actually shot the lighter with the laser, what's happening is when it blows up, it blows itself out. It's actually a trick they use to put out, like, forest fires and such, right? They've actually got, like, gas bomb. I know it seems kind of productive, but the whole point is to remove the oxygen to starve the fire. That's basically what's going on there. Just burning stuff out, blowing itself out.
got one to go up in a nice fireball, though. Oh my gosh! I did find that with this laser, I can just pour a flammable liquid on the floor and then ignite it by pointing the focused laser at it. I'm still cheating by heating the concrete to super high temperatures, but still my first handheld laser that can at least do this. It's crazy just how much power it takes to get to this point. What about snow and ice? One of my most common suggestions is to make a laser that can quickly melt snow off of driveways and sidewalks. But unfortunately, lasers suck at this.
Oh, you got the sock feet. That's gotta be cold.
Snow is highly reflective, so most of the light bounces off instead of heating and melting it. The bigger reason, though, is that ice takes an enormous amount of energy to melt. Water is incredibly stubborn thermally, and in order to get it to change phases or even temperature, you have to dump in a ton of energy. My much bigger and stronger laser welder can slice through about anything, but when it comes to snow and ice, it hardly makes a dent. Yes, that's running at the full 2,000 watts there, yet its effect on the snow is barely noticeable. The full power only becomes apparent when I hit something other than snow with it. In fact, this laser will melt steel faster than ice of the same thickness. Funny how that works. Assuming perfect 100% light absorption and ice right at the melting point, my handheld blue laser could, in theory, melt 0.75 grams of ice per second, or basically 1 ice cube per minute. This is a great example of how lasers aren't impressive for their raw power, but instead excel in power density.
Since I'm claiming that this is the most powerful handheld laser in the world, I need to make some clarifications. So by handheld, I mean something that can be, comfortably held in one hand and also has its own enclosed power source.
So an example of something that wouldn't count towards this would be my laser bazooka. It's portable, but way too big to be considered a handheld. It also sucks.
No, I think most people would still consider that handheld. They're just considered like a heavy version of it.
Another example would be my laser welding and cleaning machine. Yeah, the output is fed through a handle, but it's tethered to a 400-pound machine that doesn't
Yeah, that's correct. That would not be a handheld.
even have its own power source.
Light cannon.
So no, that's not handheld
You're not wrong, Silver. That's basically what laser is a giant light cannon.
either.
Another important distinction when I'm talking about the most powerful laser is I'm referring to CW, or continuous operation. Pulse lasers can achieve far higher peak powers, but only for a tiny fraction of a second, and in general, they're much less destructive than CW lasers.
For example, this laser I built nearly a decade ago achieves higher peak powers than what I showed in this video, but only for billionths of a second. Overall, it's a much weaker laser.
Now, funny story, I was actually contacted by a very large record book company about the original record breaker, but I didn't pursue it because it involved having the power verified by 2 independent sources. Now, don't get me wrong, this is a very reasonable expectation, but it's actually kind of hard to pull off. So a laser power meter that can measure hundreds of watts is expensive, and it's just not something that's like commonly encountered. So only a few companies and universities are going to have something like that. But the bigger issue is that most people that work with big lasers for their career aren't going to want to be near lasers like this. Like, it's easy for me to get desensitized to this kind of stuff, but no, this is a psychotic project. And I can only imagine the aneurysms that OSHA and lab safety would have over these things. And even if I did find 2 people willing to test this laser for me, it's not like I can ship it or take it on a plane with me. It would have to be within driving distance. And because where I live isn't exactly the mecca of photonics, looks like you're probably just going to have to take my word for it for the time being.
Yeah, 'cause I imagine that thing's highly illegal, right? A laser that powerful has got to be highly illegal. Something like that would be more for military applications. That laser is built for exclusive of OSHA violations. Ha 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 ha! You probably rode near Aloha. But yeah, I'm surprised another had to come in for a contract or something for that thing. Because they've always wanted weapons like that at some point in time. Especially the Japanese. Japanese were real big on it back in the day. Right. But still, with his knowledge, I'm surprised the military had to scoop them up and put them in a think tank or something.
Earlier I said that this thing is 50,000 times over the legal limit for a laser pointer. So, does that mean I'm going to jail for making it? Nope. So the cool thing about US laser law is that limit only applies to the sale and import. So there's nothing stopping me from making death rays in the comfort of my own home. Now, of course, I can't go out and sell this thing or play with it in a park, but I can show it off on a YouTube video.
One additional point I should add is that the US laser pointer limit of 5 milliwatts is actually quite lax compared to the rest of the world. Canada, Australia, and most of Europe set the limit to 1 milliwatt. So if you're in one of those places, my laser is actually 250,000 times stronger than anything you can buy. Now personally, I think 1 milliwatt is too restrictive, since that's hard to see in a well-lit room. Besides, even at 5 milliwatts, the data shows that our blink reflex is fast enough to prevent eye damage from a direct hit.
One final point I want to cover is safety. So my more recent videos have dealt with projects so extreme that I haven't even bothered with the whole don't try this at home bit, just because honestly, this kind of stuff is beyond what can be replicated without specialized tools or equipment. And yes, this laser is so far off the laser danger rating scale that its eye hazards are incomprehensible. However,
That's funny as
I want to
hell.
talk about handheld lasers
That's
that you
cute,
can buy
Aloha.
online.
If you have a laser that looks like any of these, chances are that it's quite a bit over the legal power limit and can cause permanent eye damage from even an indirect reflection. A laser doesn't have to be record-breaking to obliterate your retinas if misused. I realize this warning may seem ironic coming from me, but laser eye injuries are unfortunately very common today. I've covered this topic more in depth in some previous videos, but the gist is, tread very carefully with lasers bought online.
Now I have to say,
Yep.
I'm glad to finally finish this project and put it behind me because it felt like every single part just took way longer than expected. So a big thank you to all my channel members and Patreon supporters for sticking it out.
Yeah, that does make sense now as why they removed all that information. It's illegal to sell stuff like that. And right though you get hands on it, you about have to almost black market it. Well, it's pretty neat to look at though, isn't it?
And really for making projects like this possible. And I also want to give a big thank you to Opera for sponsoring this video. I've been using Opera for a while now, and it's the fastest browser I've ever used. On the surface, it simply loads pages quickly. Where it stands out is in its time-saving and productivity-enhancing features.
For example, my favorite feature is Tab Islands. It's crazy how quickly a browsing sesh can lead to 30 open tabs, and Tab Islands make it easy to revisit those tabs by grouping them by topic. I find this to be super useful when researching for my projects, since they neatly expand and collapse. Plus, tab traces make it even easier to find my most recently visited tabs, thanks to a subtle underline. The more recent the tab, the darker the underline. I also love the split screen feature because it allows me to open 2 pages in the same window. This is useful for all sorts of scenarios, like cross-referencing schematics, fact-checking articles, and comparing videos. It simply activates by dragging the tab down. The sidebar is great because it allows me to quickly access my various socials, and in particular, it also contains an in-browser player. I can listen to music on 6 different streaming services without interrupting my browsing, since pausing or skipping a song is as easy as hovering over the player button. I can even detach the player and move it anywhere, including outside the browser window. Opera allows me to customize my entire browsing experience with dynamic themes. These go beyond a simple light or dark mode by tailoring my browser to fit my mood. The integrated AI Aria is super useful as well. I can instantly bring up the command line with a shortcut, and then have it summarize pages, generate and interpret images, and answer questions I have.
So yeah, if you're wanting a faster, more productive, and customizable browser, you should give Opera a try and click the link in the description.
Thank you again to Opera for sponsoring this video. Well, until the next time, stay safe and happy lazing.